Hello everyone. Today we're going to be doing Module 5, Lesson 33. Our objective today is I can subtract a mixed number from a mixed number. Working with that mixed number subtraction, we started with just taking a fraction from a mixed number. Now we're going to be looking at how to work with two mixed numbers and subtract them. In this lesson, we're going to look over a practice where we just take what we learned before about subtracting fractions from whole numbers and do a couple of those problems. Then we're going to learn 3 ways to solve mixed number subtraction problems. Counting up, decompose the subtrahend, and take out 1. If these sound familiar, that's because we've done them before. The only one that's really different today is counting up, but it's very similar to counting back, which we learned in Lesson 32. Okay, so our practice today is subtract fractions from whole numbers. Let's do that now.
For our practice problems today, we're going to be reviewing how to subtract fractions from whole numbers. To start off with, we rewrite. I'm going to take out 1. I'm going to add the 2 back and add the 3/5 that I got from taking out the 1. I get 2 and 3/5. Let's do 5 minus 3/4. I'm going to take out 1. I'll take away 3/4. It gives me 1/4. That leaves me with 4 plus 1/4. Remember, I'm adding this because really what I'm doing is I'm making this 2 smaller problems. One where I just keep a 4, and one where I take 3/4 from 1, which leaves me with 1/4. I can't just eliminate this though, because this is technically part of that 5 up here. My answer is 4 and 1/4.
Now that we've done our practice, we're going to go ahead and start learning about our 3 ways to solve mixed number subtraction problems. Our 3 ways to solve are counting up, decompose the subtrahend, and take out the 1. Before we do that though, let's review some important vocabulary for subtraction. And this works with subtraction for just regular whole numbers, for decimals, and for fractions. Our large number, our minuend, is the number that we start with. The subtrahend is the number being taken away, and the difference is the part left over. Sometimes we call that our answer, right? Now that we've done our practice and reviewed our vocabulary, let's learn our 3 ways to solve mixed number subtraction problems. Our first one is counting up. Counting up is the opposite of counting back, which we learned last week. In this problem, we're going to use our whole numbers as stepping stones to make the problem easier. Remember, with fractions, whole numbers make our problems easier. Let's do those problems now.
For this problem, we're going to be learning our counting up method. To start off, I'm going to draw a number line. With the endpoints 2 and 5. Which means in this number line, I'm also going to have 3 and 4. And I'm going to have eighths as the number that I'm working with. I'm skipping here. That's for a very important reason that I'll show you in a second. But before we do that, the question we have to ask ourselves now is what fractional part can we add to get to the next one? So thinking of it this way, when we're counting up, we're kind of adding. When we move this way on the number line, we add. What do I need to add to 2 and 5/8 to get to 3? I need to add 3/8, right? Because 5 plus 3 will make 8/8, which is a 1, and 2 plus 1 is 3. So I'm going to start at 2 and 5/8, and I'm going to add that 3/8. I'm counting up. And remember, we're trying to get to the whole numbers. The whole numbers are kind of our stepping stones along the way. So the next whole number is 4. Remember, I'm only stopping at 4 and 3/8, so I know that my answer is going to be here. I'm not just going to jump to 5. I'm going to jump to the next nearest whole number, plus 1. And then I need to add another 3/8 here. Now to show that with the arrow method, I have 2 and 5/8. I added 3/8 to get to 3. I added 1 to get to 4, and I added 3/8 to get to 4 3/8. And that's our counting up method. I'm going to walk through another example now. I'm going to start with a number line between 0 and 3 because 2 5/12 is between 2 and 3. Now I have my 12ths drawn. So I'm going to start with 1 8/12 right here. I'm going to count up to the next whole number. And I add 1, 2, 3, 4 twelfths to get to the next whole number. I'm not going to go to 3 because I need to add 5 twelfths to get to my answer, 2 5/12.
To be really clear, let's go ahead and talk about how you get an answer from the arrow method. Let's do this by looking again at problem number 1.
So now that I've drawn my arrow method or written my arrow method, if I add all these together, I get my answer. So 1 plus 3/8 is 1 3/8, plus another 3/8 is 1 6/8. So my difference is 1 6/8 because this space between here is my difference.
Now let's go back to problem number 2.
So now that I've drawn my arrows, and I have 4/12 and 5/12, I can draw my arrow method. I have 1 8/12. I add 4/12 to get to 2. I add 5/12 to get to 2 5/12. If I add 4/12 and 5/12, I'll get my difference,
9/12.
And because this is a little bit trickier, I'd like to do one more example. To have more space, I'm actually going to do this last problem on line paper. So I have 9 2/6 minus 3 5/6. I'm going to draw my number line. I need to have 3 5/6 at the bottom, so I'm going to have 3 here. And I need to have 10 at the top, because 9 2/6 is between 9 and 10. I'm going to put my two numbers that I'm starting with, 9 2/6 and 3 5/6, on my number line. I'm going to start by counting to the nearest whole number, which is 4. So I count up, I add 1/6. Now I'm going to jump from 4 all the way to 9, because I'm skipping to the nearest whole number. And this is going to make my mixed number answer. So if I go from 4 to 9, I collect 1, 2, 3, 4, 5 whole numbers. And I need to count up one more time to get to my minuend, 9 2/6. So I have to add 2/6. And if I add all those pieces together, I get 5 3/6. Using the arrow method to show that, I start with 3 5/6. I add 1/6 to get to 4. I add 5 to that to get to 9. And I add 2/6 to get to 9 2/6, which is my minuend. So really what I'm doing is I'm working with the minuend and the subtrahend here. I'm adding on to the subtrahend to get to the minuend to show my difference. So my answer is 5 3/6. So now I'd like you to do the problems that are circled in problem number 1 in the problem set attached in the Google Classroom assignment.
Okay, now that we've done counting back, let's learn our second way of solving mixed number subtraction problems. Decompose the subtrahend. We did decomposing the subtrahend last week. And remember, this is good for when the subtrahend is a bigger fraction than the fraction in the minuend. We always start with the ones first. Let's do those problems now.
Now we're going to do problem number 2, where we look at the second way of solving mixed number subtraction problems, which is decomposing the subtrahend. Before we start that, though, I have a question for you. When we added mixed numbers, what was the first thing that we did? Right, we added the ones first. Right, just like in adding fractions, we're going to subtract fractions by starting with the ones first. And this sentence right here reminds us of that. So for this problem, I'm going to write it as 11 and 1/5. So my first step is to rewrite. So we're doing this problem. Now if I do the ones first, that's 11 minus 2, that equals 9. I'm really just taking 2 away from 11 and 1/5, so the 1/5 stays with that number. And I'm leaving my subtrahend fraction right here. Now here's where the decomposing the subtrahend comes in. This first process of subtracting the ones is the same for any of the next two methods. So I take away, in decomposing the subtrahend, I take away the part I need to get to the nearest whole number here. So 1/5, I'm basically matching this, and I'm putting what's left over on the other side. So if I do 9 and 1/5 minus 1/5, I get 9. And then I'm gonna have minus 2/5. 9 minus 2/5 is 8 and 3/5. Remember, a way of thinking about 9 is the same as 8 and 5/5. So if you take away 2/5, it's the same as 8 and 3/5. To show that using the arrow method, I have 9 and 1/5. That's my number I get when I take away the ones. Minus 1/5, the first part of my number bond, I get 9. I take away the other part of my number bond, 2/5, I get 8 and 3/5. Let's do another example. First start by rewriting. I subtract the ones first. 4 minus 1 is 3. I keep the 1/8 with it, and the 7/8 in the subtrahend stays there as well. I decompose my subtrahend into the matching number, 1/8, and the part that's left over, that would make 7/8. 6 plus 1 is 7. I subtract here first. I get 3 minus 6/8. 3 minus 6/8 is the same as 2 and 2/8. To show that using the arrow method, I have 3 and 1/8. Remember, I start with my subtracting of the whole numbers. I take away the first leg of my number bond. I get 3. Then I take away the second leg of my number bond. I get 2 and 2/8. If you want to see the third example, it'll be posted online on the notes. At this point, you should go ahead and do the circled problems in question number 2 of the problem set.
Now let's learn our last way of solving mixed number subtraction problems. Take out 1. We also learned this one last week, and this is good for when the subtrahend is bigger than the fraction in the minuend, just like decompose the subtrahend. And just like that, we're also going to start with the ones. Let's do those practice problems now.
Now for problem number 3, we're going to be doing our last method, which is taking out the 1. I'm going to start with that same exact problem that we did last time. This will show us how these two methods of working are similar and how they're different. For this, I start with subtracting the ones. 11 minus 2 is 9, and that 1/5 stays with. I take away the 3/5 that's left over once I take away the 2. In this case, I'm going to take out 1 from my minuend. So 8 and 1/5 over here, and 1 over here. And now I'm doing this as a separate subtraction problem. So 1 minus 3/5 equals 2/5. And this becomes an addition problem then, because I've done one subtraction problem. This piece left over needs to be re-added onto my minuend. So 8 and 1/5 plus 2/5 equals 8 and 3/5. Let's do the second one to give another example. So I start by rewriting. I subtract the ones first. 4 minus 1 is 3. The fraction stays with, or the 7/8 from my subtrahend is still there to be taken away. In this case, I'm decomposing my minuend. I'm taking out 1. I'm doing this problem. These two are working together. I'm going to add 1/8 to the 2 and 1/8 from my menu and that I pulled out, I get 2 2/8. If you need to see the last problem, it'll be in the notes posted online. At this point, you should do question number 3 using the take out the 1 method.
And there you go. That's everything we need to know for Module 5, Lesson 33.